I'm thrilled to have Eric Fogg, co-founder and head of machine connectivity at MachineMetrics. Welcome to the show, Eric.
Thanks for having me on, Noah.
Great. So I want to learn what MachineMetrics does and get your story as well. Just give me a nutshell. In a nutshell, what does MachineMetrics do? And then I want to learn how you got there and just get into lots of interesting things because I know that there's a lot of facets here to explore. So yeah, what
Yeah.
is MachineMetrics?
Yeah, well, in a nutshell, MachineMetrics is a machine data connectivity platform. So what we specialize in is connecting directly to machine controls, to sensors, to the equipment on a factory floor.
Mm-hmm.
We take that data with an edge device that we've developed that gathers that data from the shop floor and encrypts it, does a few cool things right there on the shop floor with it, forwards it up to our cloud service, where then our customers can use that data in whatever other system they want. Or we have a whole bunch of out-of-the-box reporting, dashboards, analytics that we can do.
Interesting. Okay. So now, what's your story, Eric? How did you get there? And were you always interested in machining?
Not always, although I got interested in machining pretty early on. I was lucky enough to go to a high school that had a career center, and it was my first year. I think my sophomore year, where I had a free slot where I could put an elective credit in, and I thought, should I do basket weaving or machine shop? They had machine shop, and I thought, that might be kind of interesting because
Where was
my dad.
this? What city?
This was in Brattleboro, Vermont.
Okay.
Yeah. And I thought, well, my dad used to work in a machine shop, and so maybe if I took machine shop class, it would be a fun thing to talk about with my dad. So I took the class, and pretty much day one, I remember we made yo-yos on a old LeBlond engine lathe, and I was hooked immediately. I've always loved making stuff, and so cool to make stuff out of metal and all sorts of different machines and processes, and just kind of opened up a whole world of imagination. So stayed working a lot and took pretty much every machining class that was available in that school, and at nights and on weekends and on my summers, I worked at machine shops in the area. And
as an operator?
Yeah, I started off washing parts and packing boxes, and then eventually they moved me to the bandsaw cutting parts, and then they moved me to a 3-axis vertical mill and learned how to run that. And then at home, kind of at nights and on weekends, I started trying to teach myself programming. I taught myself Mastercam, and
wow.
And then from there started programming the verticals, and then got into 4-axis, then got into horizontal milling, and then got into 5-axis milling. So by the time I graduated high school, or the year after, I was programming 5-axis milling equipment. And working on some really fun, kind of mostly aerospace projects.
So you, from the beginning, you were sort of in the mindset of combining computers and machines. You were interested in both. That's what it sounds like.
I mean, it was always, it had kind of just become the paradigm of manufacturing when I started working there. The shop that I worked at, it used to be all manual equipment. And then they got in a CNC machine, and then they kind of just, it slowly pushed out all the manual equipment. And by the time I was working there, they were down to one guy running the manual equipment. Everything else was CNCs. So, when I got started in the industry, it really started with CNC and CAD. And I consider myself a pretty decent machine programmer, and can run a 5-axis milling machine, but if you put me in front of a Bridgeport or a lathe, um, you know, I can make you a yo-yo. That's about it.
Well, so it makes me skip ahead for a second.
Yeah.
With your products, the MachineMetrics, can it track data from non-CNC machines, from cam
Yeah.
operated machines, or yeah.
Yeah. I mean, it's generally the newer the machine is, the more data we can get off of it. The older the machine is, the more you either have to add sensors to the machine to get the data you're looking for, or come up with some other creative way to figure out what's going on. But the oldest machine we have connected to our system is a 1925 punch press.
Wow.
Um, and yeah, we just installed a few sensors, a tonnage sensor, um, a couple relays to understand when the press is in its kind of push operation when someone's hit the foot pedal. And yeah, it's pretty much anything. We always say as long as it moves or has electrons flowing through it, we can probably get some useful data off of it. At least understanding if it's running or not, how many parts it's made, that sort
Yeah.
of thing.
Well, did this shop also have a lot of really high tech machines as well, or were they mostly um, more manual machines? Because I mean, it seems to me like somebody that was running all old machines from 1940s and earlier. If all their machines were like that, they might not be into being tech savvy, etc.
Yeah, it's been a fascinating learning experience for me. I mean, this particular shop did have a lot of newer machines. They're generally a fabrication shop, so pressing, stamping, turret presses,
Mm-hmm.
that sort of thing. But it's as we start working with companies that OEM their own stuff, companies that make complex assemblies of products. It's fascinating to see how many are adapted really old machines. So oftentimes it'll be a machine from the 50s or the 60s that it was built then to make this particular part, and there's really no companies around anymore that make a machine that makes something very simple, or at least in North America,
Or
maybe in
their
Asia,
crap,
or they're crap. Yeah, and these machines are they're solid
like Cincinnati
steel and
grinders. Like we had a guy
exactly, yeah.
who does Cincinnati centerless grinders, and like most of the ones that are made now, the few that are crap. They're just
Yeah.
they don't have the same casting or the same. They're made in some Asian country, and not that machines from Asian countries are bad, but like from the way he described it, it wasn't very good. Okay, so back to you. So you learned how to program. You worked in machine shops, and then you went to school. What did you major in college?
Theology was my that was my college major, and
Well, that makes sense.
yeah.
With the so were you just kind of like, all right, that stuff was really cool. That was fun, and now I want to just expand my mind in another way, or were you planning on sort of combining something that you would learn from there?
Yeah.
What was the motivation behind it? I mean, I took film and history in college, so and I use that a little bit today, but so what was the thought pattern?
Yeah, I guess sometimes you just need something a little different. I wanted to try something new and expand my horizons, but my interest was always with business, and my thought behind getting an education in theology was that I wanted to expand into corporate ethics and
Mm-hmm.
kind of use the teachings of the religions of the world to create guidelines and help companies find a better ethical path which is a very idealistic teenage thing to think. But
But
it was a
you were
fun one.
religious or you weren't religious?
Um, in my own way, yeah.
But were you
It's
into
always a
organized religion before that?
Yeah. I mean, I grew up. My family went to church every Sunday, so I certainly was exposed to the environment, and going to a Catholic university was not crazy culture shock for me.
Oh, where'd you go?
St. Bonaventure University. Um,
Okay, so
Most people don't know about it, but it's in upstate New York, kind of in the middle of nowhere.
so then where did the ethics go to? Where did that lead, or did you kind of go off on another path after?
Yeah, I kind of went off on another path. It led to some fun times and some interesting thoughts, but eventually wound up back home and working back in a machine shop. And uh, from there, decided that I wanted to branch out on my own and start my own shop. So that was kind of the start of that journey.
So what was your shop? What did you guys make?
So I wanted to start a shop that specialized in prototyping and engineering of green technology products, because I was really interested in the kind of green technology boom that was happening at the time.
How old are
Oil
you?
prices were. Uh, how old was I at the time?
How old were you? How old are you?
Yeah, I don't know. I was probably late 20s. I'm 35 now.
Okay.
Um, yeah, mid 20s when I started the shop, probably 24, 25. Um, and yeah, just really fascinated with working with companies that we did a lot of uh, unique solar panel mounting solutions. There were a lot of startups trying to come up with a better way to put solar panels on your roof. There are a lot of biofuels startups, especially in Western Massachusetts for some reason. Companies trying to come up with new ways to build ethanol reactors. Taking like biodiesel, making a biodiesel out of old vegetable oils and things like that. So there was a lot of work to machine parts for all of these inventions that these startups were coming up with.
So you thought it was a an interesting niche, something that there was demand for, something that maybe you could believe in, would give you purpose,
Yeah.
and that would just be pretty cutting edge and interesting. Was that what you were thinking?
Yeah. It was something that was a lot of fun, and I was introduced through kind of some other, business acquaintances and projects I was doing into that group of people in my area anyway. So I already knew who to talk to and ask for work.
I see. And then, so you did that a few years, and then what led you to
Yeah. So
where you are?
yeah. So we made a lot of green technology products for a while, but then the recession set in, and most of those green tech startups died in the recession.
Mm,
And I find myself doing a lot more job shop stuff, aerospace jobs and things like that. And especially given that it was the recession, the margins weren't good and it was tough work.
what kind of machines
So
were you using?
I had a couple of Haas vertical mills,
Okay.
and some other interesting Taiwanese CNC mills that were very inexpensive that I was trying to repurpose for specialty jobs. But that's a different story, I guess.
Mm-hmm.
Um, but yeah, so we the recession was a bit hard, and closed the shop, liquidated everything, and started getting into Six Sigma consulting, lean
Mm-hmm.
consulting with mostly job shops in the area. And even though the recession was on, there's also a war on, so there was a fair amount of defense work still going. So a lot of the shops in my region were quite busy actually at the time, with military related orders. So they were able to hire me and go through their shop and try and find areas for improvement. And that's kind of where the seed for MachineMetrics was planted, because I would be working on a very specific process in the shop, but I found questions like what's the utilization of this machine? How often is this machine running over the course of a shift, a day, a week, a month? Will you make your orders this week? Do you need to be buying that new machine? Really kind of basic business questions like that would go largely unanswered. Or I realized that a lot of these shops were making these decisions based on a gut feeling,
Yeah,
and the
yeah.
successful shops had a better gut.
Do you like being more on the outside advising, or on the inside in the trenches cutting metal?
Um, I'm more of a trenches guy myself. Yeah, I
Interesting.
like yeah, diving into new projects, and yeah, I'd rather be trying to figure out how to machine a difficult part and build a cell around it or something like that.
Then why aren't you
Uh,
doing that?
um, well, because I really love machine shops. I kind of consider myself a manufacturing patriot, and um, with my job now, with our software startup, I get to go into hundreds of these shops and get my hands dirty on all of their processes. So
Hmm.
it's kind of the best of both worlds.
Awesome. Okay, so now
Yeah.
give me the origins of MachineMetrics, and let's go into a little more depth. How did you get the idea? Who are the co-founders?
Yeah. Yeah. So knowing that so many of these shops are managing on a gut feeling, I thought, well, there's got to be a better way, right? And there's a lot of data on these machines. Having programmed the machines, I knew that the data was on those controls, and that maybe a good place to get started was to pull the data off the controls, and try and build some dashboards and reports and analytics to help make those decisions. So started doing some experiments with that with some of my existing consulting customers, but quickly realized that A, I think I had a business here, and B, I needed some help because being an in the trenches machine tool nerd. Starting a new company might not be the best idea for me. So um, had met previously and had heard about a guy in my area who
In the
had
New England, Boston
yeah,
area?
in the Western Massachusetts area, actually, which is a kind of small pond, so you know everybody, I guess. But he had successfully sold his previous startup that he bootstrapped, and had met him and admired him greatly, and knew that he had a background. His
What
background is in mechanical engineering.
What's his
So
name?
Bill Byther,
Okay.
yeah, and so yeah, he used to work in aerospace, designing F-35 parts and things like that with his mechanical engineering degree. And he followed through those processes through manufacturing. So he already knew a lot about the industry. And so I reached out to him and um, shared my ideas with him. And that was a little over 5 years ago now. We started the company. We formed MachineMetrics. We pulled in another co-founder, Jacob Lozier, who's our CTO, and he's kind of the software and code guru. Um, and yeah, the rest is history. We're um, past 60 people now, 400
Wow.
customers, thousands of machines connected to the system.
Okay,
So
so
it's a long journey.
yeah. So you're give me a summary of all of the different things that you track on the machines, because that's basically what you guys do. You track it, and then you kind of put it into a system and organize it for people so they understand what's going on. Correct? Is that
Correct. Yeah,
okay?
and there's a lot of different use cases and a lot of different benefits that customers can get from different pieces of data. So it can vary wildly. The most basic is just tracking utilization. So getting back to that original concept of understanding how much machines are running versus what people think they're running at. So um, one story that we always tell is since we can see the utilization data, since we're a cloud-based product, we know the utilization of all of our customers. So we kind of have like these anonymized numbers of of utilization across every machine we're connected to. And the average perceived utilization, when we ask customers before we start with them, what do you think the utilization of your equipment is at just under 80%. It's usually high 70s is where people think they are.
I was going to say that wouldn't be bad.
Yeah, well, that's world class, it turns out. The average actual is in the high 20s, low 30s.
Whoa.
So
that's 20% of what they could be utilizing their machines?
Yeah.
No, but so, does that mean could that be accounted for, like they're only running it one shift or
that's during active shifts.
That's during active shifts. So it's not it's not just like, oh, we're only running one shift and that's why we're
Yeah.
20 to 30%.
Yeah. It's usually high 20s.
And why is that? Because the people don't know what they're doing, the machines aren't maintained, what?
It can be a lot of reasons. I mean, I think some is that there isn't an understanding of what's world class, right? Like if your process is you get an order for one part, it's a complex part, you have to code it, set it up, make it, check it, and that's all that's happening. Maybe 15% utilization is world class for that type of work.
Then you're talking about low volume work.
Yeah. If you're just making onesie twosie parts, you're a job shop and you make one or two parts and move on to the next job.
15% is not bad.
Is not bad, exactly.
Why?
And that's the thing is that
I'm puzzled.
These numbers can be really surprising for people, and it's fascinating how little thought there is around where utilization should be in different market verticals.
Okay, well, what about like a lot of our listeners? You know, we have a whole mixed bag. Some people are doing low volume, but many people are making, 10,000, 50,000, millions of parts.
Right.
Are they often even less efficient, and it's really easy to get lost in? I think it would be even harder to track, or even harder to be up to your full potential when you're doing that.
I mean, those shops definitely have much higher utilization rates. So we do have some customers that, they make parts by the millions, and their utilization rates can be in the 90s. But generally, those shops also have much thinner margins. So the difference between going from 90 to 93% utilization can make a really big difference to a bottom line.
Oh, so the people with the high volumes are often better at getting their machines utilized than the people with the onesies and twosies.
Yeah. But
interesting.
Across the board, almost everybody is shocked at what theirs actually is. That's kind of the one commonality. If you think you're 90 and you're 80, that's shocking. If you think you're 50 and you're 15, that's shocking. And that's oftentimes the news that we're delivering to our customers very early on is giving that baseline utilization number.
Okay, so now why? What is the main culprit?
There's a lot of
top 5 things.
Yeah, I mean, it varies almost by every shop. It's another thing that makes this job interesting, right? Is as we start working with each company, it's like, oh, that's what's holding you back. But I mean, there's a lot of stories that I love to tell around this. One is just around tool changes. So we had one customer that they have a couple cells that run a high volume. So these cells were set up to make this part. They make them by the thousands every week.
What machine?
It's like a robo drill style drill tap centers fed with robots.
Okay.
And they put in a cheap 1/4 inch drill because there's one little hole in the part that's 1/4 inch and it's not that important. And just buy a cheap drill bit, throw it in there. And how long does it take to change a 1/4 inch drill bit? Right, 5 minutes. Right, you touch it off, you put a new one in, press the green button, you're good to go.
Mm-hmm.
But what we found when we hooked MachineMetrics up to the system was, sometimes it does take 5 minutes to swap out that 1/4 inch drill bit. But sometimes when the operator is on their way to the tool crib to grab a replacement, someone says, "Hey, Eric, hey, can you come over here and
Yeah.
help me out with this problem?" So then you're helping somebody else out with a problem. Machine sitting idle. Then it's lunchtime. Machine sitting idle. So even though the customer perceived that every tool change should be taken 5-10 minutes, the average was over 40 minutes to change that tool. So
Really?
that's something that we can track.
So in your opinion, then maybe either you could get a better tool or the process would be changed so you weren't trying to multitask.
Yeah. Well, and that's exactly what happened, right? The owner of that company looked at that number and he said, um, why are we cheaping out on this cheap, high speed steel drill bit? If we're losing 40 minutes on average several times a day, go out and buy the most expensive drill you can find for this job. And they did. They
Was
went out and
that
bought
was that the best answer, or was it
that.
really the process that was the main problem?
Well, I guess there's a lot of ways you can attack it, and that's up to our customers. They can attack it however, from easiest to hardest. So
And
yeah,
what was the
I think
bigger
there's
in that case, for instance? What was the bigger problem? Was it just the system and the people, or was it the tool that they were using?
yeah. I mean, I do think it's both, right? It's the system and the people, but that's a hard problem to tackle, right?
Right,
Because
right.
there's those 40-minute average. There could be 100 different things. Say you changed 100 tools and the average was 40 minutes each time. There could be 100 different things that operator came across that delayed him or her to get that tool change done expeditiously. So in this case, the easiest solution is just
Right.
buy a tool that's going to last way longer. Um, and uh, and so they did. They bought a tool that lasted 10 times longer. So instead of changing this drill bit, 3-4 times a day, they were changing it a couple times a week.
So
So even if it's still,
your company, you find the data, and then is part of your service to actually tell them, give them a prescription what to do, or is it kind of like self-explanatory? Are you providing two different services, like hardware and inside, or how's it
we
work?
we don't do a lot with the insight. We do have a customer success department that works with each customer in perpetuity and helps them go over their data and try and find the useful data. But we found that you put this data in front of the customers are generally hungry for it, and they find the valuable
Yeah.
decisions to make very quickly. And we're the ones that are learning. We're watching how they're using our data, and we're always amazed and surprised at what uses people come up with, and the problems that they solve.
Right. Well, I mean, buy a better tool. Like, that's pretty simple. Are they like the suppliers, like for instance the tooling people, are they going to you and wanting uh, data from you
Yeah, well, I mean,
so they can go to
uh,
their customer and say, "Here's the ROI, blah blah blah."
exactly. Well, and customers are doing that themselves. So it can happen from either angle. A tooling company can come to you and say, "Hey, I'll install this system on your machine. Then I'll put my product in the machine and prove to you what the value is." But the other direction happens very often too, where our customers have a salesperson come in and they say, "Hey, buy this tool. It'll be 10% better."
Mm-hmm.
And our customers now are able to say, "Okay, give us one. Let's go out and throw it on
Yeah.
the machine right now. And we'll look at the MachineMetrics data and be able to tell you if it's 10% better or not. If it is 10% better, you got yourself an order." Um,
That's so cool. So give me another example. Like that's a seems like a very straightforward one. Give me another example of a metric you guys would do, and
yeah.
what happened.
Yeah. I mean, I think, I can give you a lot overall. I think, what we've learned is that the biggest culprits on a shop floor, it's more death by a thousand cuts, right? There may be some big issues on your shop floor that that your team is already spending a ton of time working on, right? You don't need a software company to come in and tell you that you're losing 40 hours a week because of this big issue, because you probably already know. Um, but generally, those big problems that you already know about are really difficult to solve, and you're really banging your heads against the wall trying to solve those. Meanwhile, there's 1,000 little 5 and 10 minute things that are happening all over your shop that you're not seeing. And that's what we bring to the surface. And what we've found is, even though there's so many of them, they're often very easy to solve. So another one that I find really fascinating, and this is not something that I was taught when I got my lean, Six Sigma certification and things like that, is cycle creep. Cycle creep is something that is an epidemic, especially in the CNC industry.
Cycle
and
creep.
Yeah. And basically what that is, I mean, it's a coin that we kind of termed, but maybe it's not original to us. But say you program a job, you set it up on your machine, and it takes a minute to make that part. Over time, if you keep running that job, people make little tweaks. People change a tool, they change a feed rate, they'll do this, they'll do that. And over time, that cycle time changes. But what's in your books, what's in your ERP system, what you're billing the customer for is a minute apart. But 6 months, a year into manufacturing that part, it's actually fairly rare that the cycle time is what you set it to.
And wait, is it usually improved or not?
It's usually getting worse. It's almost always getting worse.
Really?
And
do some
example,
people expect that it's getting better? I think people would think, oh, well, I keep tweaking it and fine tuning it, and
Yeah, and I think there probably are some cases where it gets better, but a majority of the time, at least that we see it, it's getting worse. Usually, if it's better, it's expected, right? It's like, hey, I bought that new tool that's 10% faster, so I'm going to lower my 60 seconds to 50 seconds. And you can bet that that's going in your accounting system, right?
Right. Is it because people are sort of using a Band-Aid?
Yeah. I mean, some of it I still don't know. One example is I was in a shop. Part of our sales process is we'll hook up to a machine right when we're there. It usually takes us a couple minutes depending on the machine, and connecting to a Swiss machine for a medical company that OEMs their own parts.
Mm-hmm.
And
it's kind of like you're coming in and you're giving it a physical.
Yeah, exactly. So we hook up to the machine, and then we all sit around the conference table and we pull this machine's data up. And so I pull up the machine's data, and I can say, all right, well, I can see here that the machine's run a couple cycles, and you've got a 1 and 30 second cycle time. And immediately someone was like, well, that's wrong. It's a minute. And they were thinking that the data coming off the machine was wrong. I said, well, it really looks, we can see the whole cycle of the machine. We can see each tool change. It's taken 1 and 30 seconds. And one of the guys gets up from the table and he's like, I'm going to go check it out right now. He goes out on the shop floor, and I kind of keep going on talking about the software and their shop. And he comes back and he says, I fixed it. It's back down to 1 minute. And the general manager of the site was like, you're kidding. Like, what did you do? He said, one of the tools was set to run a second time. It was basically like a boring bar running a spring cut. So at some point in the process, an internal diameter was a little undersized. So an operator or somebody just ran that tool a second time, just kind of tacked it on and ran it a second time. And the parts were coming out to size if you just ran that same tool a second time, instead of tweaking the offsets of that tool and doing the right thing to get it cutting right.
And the guy just went out and then in a couple minutes was able to reprogram it.
He took off that second run of the tool. He adjusted the offsets, got the machine making good parts again. But so and these are real numbers. It was around 1 and 30 seconds, and he brought it down to 1 minute.
Wow!
So that's a 50% increase,
right? And this is probably an expensive part.
I mean, a fairly expensive part. But the crazy thing is that that machine had been running that part for years. So sitting around the table with these guys, they were like, we honestly don't know when this problem happened. It could have been running this way for a year or more.
Were there a few machines? Were there a few machines running the same part? That was running.
I don't believe so.
Okay.
Yeah, I think they kind of had machines set up running their own unique part numbers. So yeah, just a great example of cycle creep. And for them, they got a 50% productivity boost. But It's fascinating because, you walk around the shop floor and all the pat lights, all the stock lights are green, right? So you just assume, well, machine's running, the light is green, we're good. But in this case, no, the light might as well have been red half the time. But that's a simple transparency that you don't see when you're just looking at, is the machine running or not?
And that is a case of just they could improve on people, and they can improve on people to watch their people, I guess.
Yeah, I mean, it's also so many of these cases. We never really see many instances where somebody is being malicious, and it's generally people are trying to do the right thing. It's just sometimes people don't know what the right way to program that machine is. Or my guess is in that case, somebody ran that tool a second time because they just needed to set it up quick that way, and they were planning to come back later or talk with their supervisor about it the next day, and conversation never happened, and then it was forgotten. So it sounds like an extreme example, and I thought it was an extreme example when it happened, but it turns out that it happens a lot. One other really quick example that I'll give is we have another customer that has about 20 or more 400 millimeter horizontal milling machines.
Mm-hmm.
And they're all in a row, really nice, beautiful, all the same machine, same model, same make. And the OEM of those machines had programmed them originally to come on site turnkey. They're all making the same part, or they're all making the same family of parts. So, but they bought these machines over the course of 10 years. So gradually, one at a time, these machines come in, they're programmed, set up to run the job, get added to the line, and put into production. But all making the same part. The expected cycle time was 40 minutes,
Mm-hmm.
Something like that, 42 minutes, something like that, for a whole pallet to be completed and swapped out. Of the 20 or so machines that we were connected to when we did this study, no two had the same cycle time. And the delta...
No two out of four had the same cycle time.
No 2 out of 20 had the same cycle time, and they were all making the same part. Some of them were only a few seconds apart from each other.
Okay.
But the delta between the fastest machine and the slowest machine was 15 minutes.
But why didn't the company already see this?
Green lights, right? That's what they were checking for. All the machines were loaded, lights were green, chips coming out the back end of the machine into the chip, bin. Everything looks good. So yeah, we hooked up to these machines, and within a week, they had all the machines tweaked in to within a couple seconds of each other's cycle time, which was a tremendous savings for that company, and a really simple ROI. It took less than a week to understand it, to reprogram it, and do it.
So this must be a once you give your spiel to people, I'd think this would be a pretty easy sell.
Yeah, I do think in a lot of ways it's an easy sell. The hardest part is what we were talking about a little earlier, which is that oftentimes we're delivering bad news.
Yeah.
And it doesn't have to be bad
it's uncomfortable
news, right?
too, because that means that, sure, buying another tool, no problem. Even buying another machine, no problem. But just changing, an ERP system or a CRM or a way of having people's schedules or whatever, like that, it's annoying, and then I'm sure it's just tough for people to hear. So is that part of your job, or the people's job of your company, to like be empathetic and talk to people in a way that they're able to deal with this stuff, and maybe, I suppose, you also try to come up with certain data to make people feel good about themselves?
Yeah. It's certainly our job to walk customers through the data that they're seeing, and share the change management lessons that we've learned with other customers. So that's kind of the genius of the SaaS model, and a customer success manager being assigned to accounts, is that you get a little bit of like the wisdom of the crowd, right? So we are really in touch with every customer that we continuously work with every day, and we learn the best practices from them and
Yeah,
pass those best practices on to new customers.
that makes
Um,
sense.
so because everything that we've thought we knew how it was done, it turns out it's all wrong, right? When you're actually in a shop, and so many shops are different by vertical, by the type of work they're doing, the game completely changes. But the thing that is consistent is having a culture around change in your shop, and that's often a really hard thing,
Oh, it's so
for any
uncomfortable.
business.
Change
Um,
is sucks.
yeah, and it's in a lot of ways, it's not in human nature, right? It's most people are stressed by moving their homes, right? It's to move into a new place, even if uh, by the books, everything about it is great. It's a bigger place, it's a better location, whatever. But it's really stressful to do something new and uncomfortable, and a kind of a step away from
Mm-hmm.
that home like feeling of the way you had been doing things. But it's if it is actually a better world, um, where you're moving, it becomes easy quickly. So I think that's a lot of our job, is to show that better world as quick as we can, to get people comfortable with
So
the
you would
changes.
you would say that the uh, like one of the signs of a business that's either successful or on the ball is them being able or embracing change.
Absolutely. I mean, I suppose I'm biased, but I mean, we have customers that
And
excel
growth.
with our product.
Yeah.
Exactly. Yeah. And we have customers that excel with our product, and we have customers that struggle with it. And to cast wide strokes, the customers that excel are the ones that have the best culture around change, and the ones that struggle are the ones that struggle with that the most. Um, and I could also, once again, drawing broad strokes, but those companies that are excelling with our product are also probably the fastest growing companies that we work with.
Yeah.
Um, and it's not just because of MachineMetrics. We like to think that we are a big part of their growth, but it's that culture that they have of accepting the change, and being really open, to their lives being disrupted by new technologies and trying new things.
Do you find a pattern with younger people and older people? Are younger people more likely to embrace change, or is that not a fair assessment?
It's hard. It varies. I mean, there are definitely young people that embrace the change. Oftentimes, if it's a software system, or a visualization system where you're setting up flat screen TVs on your shop and putting up dashboards on how things are
They're
going.
less afraid of that.
Yeah, in general, young people are like, oh yeah, that's my life. That's put up more screens. I'm used to it. But I have found, just from my own going around shops, um, that oftentimes the older guys are unfairly maligned, for not being open to it. I
Yeah,
think
yeah.
a lot of them too are their company's best interests in mind, and even if
Sorry, you
putting up
cut.
screens everywhere is a little skeptical.
Um,
Yeah, go ahead.
yeah, you cut out for 1 second a second
Oh,
ago.
sorry. Yeah, so but I have found that with the older guys,
Yeah,
sometimes they're unfairly maligned, and that generally a good employee is a good employee, right? If you have an employee that cares about the company, they care about the competitiveness of the company, and doing whatever it takes to stay competitive, because they know um, that helps them keep a job.
mm-hmm.
We've found generally age doesn't matter, but there certainly are, some older guys in shops that are near retirement, and they're like, look, I'm not going to learn this new computer system. I can make parts on a machine, and I'll keep doing that. Um, so
Yeah. So this seems like theoretically it could be applied to any kind of business, but it's easier to quantify when you're looking at actual equipment. But I mean, you could apply it to other applications, right? I mean,
Yeah, I mean,
it's consulting, really. I mean, it's taking a holistic look and more micro look at things as well. I mean, I guess you're the way it seems is you come in and you zero in on one machine or a group of machines, and then that kind of like spreads out to looking at the whole company. Like it's it's kind of the germ, and then after looking at one machine, I bet you that can demonstrate various trends about the whole company. You'd say that's true?
yeah, yeah. I mean, I would say our customers often will apply the 80/20 rule. So they take their 20% assets that just aren't super
Mm-hmm.
important or high margin or whatever, and they don't include those in a project like this. And they put you start with the most expensive, highest margin assets and work your way down. Um, and our customers can set the system up however they want, but we have found, kind of part of the change management um, methodology around this is that you really do have to, you dip your toe in and then you got to jump in,
Yeah.
because it sends mixed messages to the company if you go out to your guys on the floor, like, would you do this with an ERP system or a new machine? Would you say, hey, we're trying this out. We know it's really different from what we've done before. So, if as managers you're saying to your employees, we haven't made any decisions on this. Let us know what you think. Generally, people who are adverse to change are always going to say, well, we don't like it. We want the old thing back because we
Yeah.
were really
Yeah.
good at that old thing. But if you dip your toe, you understand exactly what you need to get out of the system, what your return on investment is. You test it out, and then you go out on the floor and you say, look, this is what we've decided to do as a company to stay relevant and competitive. This is the direction of the business. You'll find that throughout the whole organization, everyone says, all right, yeah, well, if that's part of my job now, if that's the way the business is going, then I'm going to learn how to do this thing well. I'm going to
Yeah.
try and figure out new ways to leverage this data to help the company.
Because it just sounds, unfortunately, it sounds like, yeah, buying a new piece of equipment is that's the quick fix. But unfortunately, that's only going to improve you so much.
Right.
Sounds like the habits, the philosophy, the management. Unfortunately, that stickier, harder stuff. That's that's what's going to really make the change, isn't it?
Yeah. Yeah,
Um,
absolutely. You got it.
you mentioned a few things in passing. This fourth industrial revolution. What's that?
It's a good question. I think
I
that's
thought the industrial revolution was its own revolution, and now it's like the information revolution, or no?
yeah. I mean, it's certainly one of those things that I don't believe there is a widely accepted definition. Yeah, I think there's a lot of thoughts around what the fourth industrial revolution is. Other people talk about the industrial Internet of Things, or Industry 4.0 is another way of saying it. There's a whole bunch of buzzwords out there. Some people are using it to try to understand what's going on, and some people are using it to try and sell stuff. And I think that's always a problem with buzzwords, right? Is that once those buzzwords start being used as just as a sales term, everyone gets confused and not so sure what any of it is, including myself. I don't really know. And sometimes I ask, well, is the fourth industrial revolution actually here? How would we know if it was? I think my software is great. I think that connected machinery is great. But is that alone the fourth industrial revolution? I actually don't think so. I think it's a higher level of connectivity that we're aiming for, and that's becoming more and more possible, that enables another level of automation that doesn't exist right now. I think that's really the fourth industrial revolution.
What countries are is Europe more efficient, or Asia more efficient than we are? Do you have metrics on that?
So we do have some metrics on that, but it's hard because the type of work is so different. Um,
Mm-hmm.
Generally, a medical shop in China is going to be very different than a medical parts shop in the US as far as the work they do, the complexity of it. Um,
Okay, but if you had to
so
stereotype, or you refuse,
yeah, I mean,
you're afraid to like draw any generalizations because it's too complicated to say anything.
I would say from my experience, the Germans especially are much more open to trying new technologies quickly.
Mm-hmm.
Where in North America, there's a lot more proof that needs to be made before someone makes a decision. I think generally in markets where um, labor is much cheaper, margins are much thinner. So to get really automated equipment or really advanced software into those places, it doesn't make a lot of sense, at least at Western prices.
Mm-hmm.
So I think that's yeah, that's
Thank you, Eric. Before we wrap this up, is there anything else that you want to say to the world as far as your thoughts on manufacturing, thoughts on the future of people's productivity with their equipment, etc.?
so much to say. Do you have another hour? Um,
Yeah, well, I as you mentioned before,
Get the juices flowing.
maybe we could do this again sometime. I uh, yeah, you have a lot of interesting thoughts, and I know there's a lot more questions we could ask about how it's implemented, how they put the data into their systems. But I just yeah, I any conclusions you've drawn from you've been at this company 5 years,
Yep.
so what are a few uh, takeaways?
Yeah, I mean, I do think that one of the biggest takeaways is I mentioned it a little bit earlier, but that there's a lot going on in shops that they're problems that are easy to solve, but they're a thousand tiny little things, and getting that stuff to the surface is really imperative for shops to be competitive in the future.
Yeah,
However you do that, I think that's one of the most important things, is to actually take a moment and not focus on the really huge problems and try and find the small ones, because there are a lot of them.
yeah, yeah. But
I think,
it just seems like what you touched on as far as the emotion. It's so running a business is so emotional, and you're
yeah,
these machines is hard data, and you're matching that with emotion. So it seems like
yeah,
you have to be in touch with that.
yeah, and you're adding the additional spice of really expensive assets in there too, right? These, the capex on this equipment is, makes your eyes water. There's a lot of thought and pain and work that goes into deciding to buy a $250,000, $500,000 piece of equipment.
How much does
Um,
your equipment cost, and how do you just? It's kind of like a. I remember what you told me before, which sounded really interesting. The one of the main hurdles you had was coming up with something that could adapt to so many different pieces of equipment. But what's the process? I mean, you take, you kind of go and you give these machines a physical, but what are you putting on the machines?
Yeah, so we really just add our edge device to the machine. It really depends a lot on the machine, the type of control it has, the type of interface. Are we adding sensors or not? Is it a new machine? Is it an old machine? So there are a good few variables in there, but in general, we put our edge device on the machine, connect up to its control, and start pulling data off of it. And our hardware, even if you're including sensors, is it's just a couple $100. That's not our bread and butter. What we charge is a subscription around the software,
Ah,
because we're not selling a tool. We're selling a platform that is intended to bring companies along a journey, kind of in perpetuity. So,
how much does it cost, the subscription?
it varies a lot. To just quote a number, I wouldn't want to quote something to your audience, but yeah, it varies depending on the types of machines and the type of data that you want to get out of the system.
Mm-hmm.
But generally, I would say that our customers often will get a return on investment of weeks with our system.
If they use it.
If they use it, yeah. Well, and the thing is, it's like the cool thing about it is you really just need one big win or a couple small wins, right? So it's like you install a system like this and you find cycle creep on a process of 50%, right? Boom, just paid for itself. Done. Everything on top of that is gravy. So oftentimes there are some really early wins that we can get that, that not only just pay for the product and bring that ROI number into something that makes everybody happy, but also helps us get credibility with the employees at that shop,
mm-hmm.
right? It's like, oftentimes people are skeptical. Oh, there's a new system. What can it do? I don't know. It's just, but then all of a sudden, like, boom, wow, we made this really big change that really impacted the bottom line and everyone's happy. And, now all of a sudden we've got a lot of credibility and not just the managers who bought the system, but everybody on the shop floor is going, like, what else can this thing do?
Well, it's good to hear that people. It's good to hear that there's a good reception and people aren't just so scared or lazy.
Yeah, almost always our customers think that there's going to be a lot of fear from their employees around a system like this. Almost always there is, very briefly initially. But also almost every time within a couple of weeks, everybody loves it. So
I'd be afraid, but
until it starts making your job better.
Yeah.
And then you change your tune pretty quick.
Well, Eric, I really appreciate it. Thank you so much for the interview. And if people want to find out about your company, where should they go?
Just check out MachineMetrics.com. Everything you need, you'll find right on our website.
Awesome.